Welcome to the Walton Pi. Today we're going to go through some examples of taking derivatives of inverse trig functions. Let's suppose that we want to figure out the derivative of f of x equals inverse sine of 3x minus 7. One thing we could do is, if we can remember the derivative of inverse sine, then we can just take the derivative of that and use the chain rule. However, I have a very hard time remembering them, and so I always approach these through the eye of implicit differentiation. So if we say that y is equal to inverse sine of 3x minus 7, then that tells us that sine of y is equal to 3x minus 7. And so at this point, I then take the derivative of everything with respect to x, and I just do implicit differentiation to figure out what that's going to be. So the derivative with respect to x of sine of y, we are going to have a chain rule come out. So the derivative of sine is cosine of y times dy dx, and that is going to be equal to 3. So that means that dy dx is equal to 3 over cosine of y. Now, cosine of y, that is going to be equal to 3 over cosine of inverse sine of 3x minus 7. So if you know what that is off the top of your head, more power to you. But if you're like me, you probably can't figure that out without drawing a picture. So if we have some angle that's y, we know that y is inverse sine of 3x plus 7, or in other words, sine of y is equal to 3x minus 7, and sine is opposite over hypotenuse. So that means if we make our hypotenuse 1, and then our opposite would be 3x minus 7, then this last side is the square root of 1 squared minus 3x minus 7 squared. So then if we were to try and figure out what is cosine of y, well, cosine is adjacent over hypotenuse, so that is going to be the square root of 1 minus 3x minus 7 squared. So that tells us that the derivative, so dy dx, is going to be equal to 3 over cosine of y. Cosine of y is the square root of 1 minus 3x minus 7 squared. And that would be how I would approach figuring this out, because derivative of y was f of x, so that is f prime of x. So that is how I would approach this problem. I don't actually have the inverse sine, inverse cosine, inverse tangent. I don't have any of those memorized. I approach all of them through the lens of implicit differentiation. So let's just do one more example together. Let's say that this time we have f of x equals inverse sine of 3 plus cosine of x. Well, again, we are going to just say this is y equals inverse sine of 3 plus cosine of x. So that tells us that sine of y equals 3 plus cosine of x. And we are going to do implicit differentiation here as well. So actually, let's change the sine to inverse tangent, just so that we don't use the same trig function we did last time. So if f of x is inverse tangent of 3 plus cosine of x, then we have tangent of y equals 3 plus cosine of x. Taking the derivative with respect to x of both sides, the derivative of tangent is secant squared. So we have a secant squared y times dy dx. That is equal to the derivative of 3 is 0, and the derivative of cosine is negative sine of x. So we got dy dx equals negative sine of x divided by secant squared of y, which is negative sine of x cosine squared of y. Well, all we know is tangent of y is 3 plus cosine x. We need to figure out what is cosine of y. So if we were to draw our triangle, we have our angle y, and we know tangent is opposite over adjacent. So if we make adjacent 1, then this is going to be 3 plus cosine of x. So that means that this side is the square root of 1 squared plus 3 plus cosine of x squared. Cosine of y is going to be adjacent over hypotenuse, so that is 1 over the square root of 1 plus 3 plus cosine of x squared. So that means that cosine squared of y, that is just going to be 1 over 1 plus 3 plus cosine of x squared. So what that tells us is that f prime of x, which is our dy dx, that is equal to negative sine of x times cosine squared of y, which is this. So negative sine of x over 1 plus 3 plus cosine of x squared. That is going to be our derivative. We would have gotten the same thing if we used the chain rule and remembered the derivative of inverse tangent. But again, I have a really hard time remembering those, and so I approach these through implicit differentiation. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already, so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.